Hello, first period. I'm really sorry. I didn't give you guys any kind of warning that I wasn't going to be here. Some of you are probably like, yay, she's gone. Some are like, oh no, where is she? I totally forgot my son has an appointment today, so I am at the doctor's office with him, and you guys have a lesson to do, which is super lame for Halloween, but you guys will all survive. Okay, we are on page 187. Graphing proportional relationships. Remember, proportional means starts at 0, 0. Is a straight line. Which means it's linear. It's just a very special linear because that starts 0, 0. And it has a constant rate. Here's a graph that could represent a variety of different situations. Write an equation for the graph. So just like right here, you wrote this down. And it was y equals mx, where m is your slope. Your y over your x. What's your rise? What's your run? All right, so our equation, y equals, I'm just going to go all the way up to here because there's a dot there for me. So start at 0. It went up to 14. And it went over 8. However, that is, you can simplify that. They're both even, so you can just divide by 2. That's the first easiest step, I guess, when they're both even. Half of 14 is 7. Half of 8 is 4. There's our slope. 7/4 x. Sketch a new graph of this relationship. These numbers are way larger. They are similar to these, but multiplied by 10. These, I mean, there's probably some sort of multiplier. So we need to know what point we can get to based on these large numbers. So if I have 7/4, I see 40 and 70, so I can multiply both by 10. And I get 70/40 would be my slope. So up 70/40, which looks like it's going to be the same as 35/20. If you divide both the top and bottom by 2 to simplify it, 35/20. So that means it goes right through the center of all of these. So it's almost like the rise is up 1 and the run is over 1 because you go up 1 square and over 1 square. Just the values aren't 1 and 1. So this first part, I'm not going to give you cards because I'm not here. It is what it is. 2 large water tanks are filling with water. Tank A is not filled at a constant rate. See how there's just a little bit of there's a little curve there and there. Okay, that's okay. Tank B is filled at a constant rate of 0.5 liter per minute. The relationship between volume of water and time can be described as V equals 1/2 T, where T is minutes and V is volume. Look at this. This is also my Y. This is also my X. So my equation is still the same. Volume was V, it could be Y, is 1/2 of the time, which is X. So it still works. Sketch and label the graph of the relationship between volume of water, V, and time, T, for tank B on each axis. Axes? So for every 1 minute, it's 1/2 of a gallon. So it's half a gallon in minutes. So if I put this 1, I get half a gallon. So I don't have half, but half is between 0.6 and 0.5. Make it a little bit better? Maybe not. And that's at 1 minute. So at 1 minute, half a gallon. This is 2 minutes. So that means at 2 minutes, it's 1 gallon. Looks like this one's filling up way slower. Already on this one, these are all multiplied by 20 by 100. Because this is 2/10. This is 20. So we multiply these by 100 and these also by 100, or we can fill it in. So in 20 minutes, so volume equals 1/2 times my minutes. So volume after 20 minutes would be 10. So what if I do another point? Volume is 1/2. Let's do 80. Volume would then be 40, because half of 80. I have 2 points. I can now connect them. Make sure we start at 0, 0. So sketch and label on both of them. We did that. On the next page, there's a couple questions. I'm just going to read them, and we're going to look at it over here. After 30 seconds, which tank has the most water? So this is tank A. No. Tank B, sorry. This is tank A. So at 30 seconds, well, here's 1 minute. Here's half a minute. Who has more water? B. At approximately what time do both tanks have about the same amount of water? So now we're looking at this one. Well, it happens somewhere in this time frame. So we could cut it right in the middle and do 50. But it would be somewhere between probably 45 and 55 minutes. At approximately what time do both tanks contain 1 liter of water and 20 liters of water? Well, here's 1 liter of water. And here's 20 liters of water. So we got this point. We got this point. And we got this shared, not quite shared point, but it's right in there, that point. So 1 liter, 20 liters. 20 liters is going to be super similar. You could use the equation to actually solve for it for tank B. That was it for the lesson. Your homework will be, let's look at it. Number 1 for sure. Talking about the tortoise and the hare running a race. After the hare runs 16 miles, the tortoise has only run 4 miles. The relationship between the distance the tortoise runs in miles for every mile the hare runs is y equals 4x. So you would create a table. So that way you can have some points to plot. Well, if x is 1, I plug 1 in, what would y be? Well, 4 times 1 is 4. Maybe find out what would 2, I don't know, 4. You might be able to fit 5 in. what would each of these be, and then plot it and graph it. The table shows a proportional relationship between the weight on a spring scale and the distance the spring stretches. So you need to do a lot of filling in. So first you would want to figure out how to get from 20 to 1. Well, when 20 divided by 20 is 1. So what is 28 divided by 20? 28 divided by 20 is 1.4. Well, 1.4 is kind of nice because you can multiply it by a certain number and to get 140. Because it's the same number, your decimal place is moved. Next, 1 is a nice number because you can multiply 1 by something specific and get to 55. So what do you multiply by? Maybe this should be at the bottom. 1 times what is 55? You're going to multiply this number by whatever number you multiplied here. Same with this one, my blue. What do you multiply by here? You're going to do that same number there. Describe the scale you could use on the x and y axis of the coordinate grid that show you the distance. Do we have a coordinate? No. Okay. Well, if this is my x and this is my y, here's my labels. What is the slope? Remember, slope is rise, run. On a proportional graph, it's just your y coordinate over your x coordinate. What is y? What is x? What do they mean? On the back, find a sequence of rotation to go from big to small, but we don't use circular grids. So if you want to do it, you can. You don't have to, though. 4. Andre found 2 figures that are congruent, so they can't be similar. Diego says, no, they are similar. The scale factor is 1. Do you agree with either of them? Use the definition of similarity to explain your answer. This one you do have to do. Honestly, what do you remember out of that? That was just the last unit, but before slope. So you are doing 1. You are doing 2. You can do 3 if you want to, but you don't have to. And you are doing 4. After you finish it, go into Google Classroom. Look up your GimKit assignment.